While we are highly trained professionals dealing in complex mathematical procedure, we do encourage you to try this at home as it will enhance your understanding of mathematics and hopefully improve your exam grade. So welcome to 1 Lesson 3 Math. The learning objective of this video is to be able to apply Pythagoras' theorem and trigonometry to 3D shapes. The lovely cuboid on the left is called A, B, C, D, E, F, G, H. The sides A, B, BC and GC are in the ratio of 7 to 3 to 4. Find the angle the line AG makes with the plane ABCD. Now, if you would like to have a go at this video, please pause it now before I proceed with the solution and explanation. So, we need to find the angle that the line from the corner, the point A to the point G, makes with the base, the plane ABCD. Now, more often than not, on exam questions where you have to apply Pythagoras and trigonometry to 3D shapes, to cuboids, it's a good idea to note on the diagram in pencil, in case you need to rub it out, what information you have. Now, because we're finding an angle, it doesn't matter that we don't have the actual measurements of the sides, because with similar shapes, one thing that remains the same as the size of the shape increases is the size of the angles. And we're finding an angle here. That's what we're aiming for. So what we can do is we can note that AB is 7, BC is 3, and GC is 4. Now, more often than not in these questions, you need to find the diagonal of the base. Now, I'm looking at this question, I'm thinking, can I create a right-angled triangle for the base? Well, yes, I can. And I have 2 of the measurements. So another good idea for these questions is to actually draw the triangles that you have. Just sketch them in the working out space given on the exam paper and label what you know. So we've got 2 sides there, 3 and 7, and we can work out the diagonal using Pythagoras' theorem. So the longest side would be C, the 2 sides that we have are B and A. They're interchangeable, but you've got to make sure that you label the longest side C. So now we write down Pythagoras' theorem. ABC squared 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 plus equals Pythagoras 5. Then we start to sub in the values that we have. 7 squared plus 3 squared equals C squared. We work that out, show all of our working out. 49 plus 9 equals C squared. So C squared equals 58. And obviously to find the length of that diagonal, we're going to square root 58. And that gives us 7.616. I've written it to 3 decimal places because I want to ensure accuracy when I'm substituting in the next part of my solution. So now we know the diagonal. Now we can form another right angled triangle using that diagonal and involving the line AG, because we know that GC is 4. So the next triangle that we're going to use is going to appear soon. So here we are. This orange triangle is our next point of action. So again, I'm going to draw the triangle. Now it's this angle here that we're going to work out, and we have the measurements 7.616 and 4 as our 2 sides. So obviously with Pythagoras you're using 2 sides to find another side, but with trigonometry we're always involving one angle, not the right angle, and 2 sides. Okay, in this case we have 2 sides, so we can work out this angle that the exam question is asking us to work out. So, what do we do? Well, the first thing I always do when I'm working out a trigonometry problem is I write down SOH CAH TOA and I identify the sides that I have and the side that's not involved. So the hype's the longest side, the op is the one that's opposite the angle. So, I'm going with my cursor there from the angle to the 4. That one's the opposite one. The adjacent side is the one that has the angle and the right angle on it. So 7.616 is the adjacent side. So now, we're not using the hype, we're using the op and we're using the adjacent. So therefore, we're not using SO and we're not using CAH, so we're using TOA. And what does TOA mean? T-O-A, tan x, the angle, is opposite over adjacent, opposite divided by adjacent. So now we're going to start to substitute our values in. So we've got tan x, we don't know the angle, so we can't substitute that in, equals 4 over 7.616. So now, to work out x, we need to do the inverse function of tan, which is tan to the minus 1. You can get that by pressing the second function button on your calculator and the tan minus 1, which is just above the tan button. So x is going to equal tan minus 1. Make sure you use your brackets accurately. 4 divided by 7.616. Enter this into your calculator. Hit the equals button. You get x, which is the angle that we're trying to work out, equals 27.7089. Write down a number of decimal places just to ensure accuracy, and then if the question asks you to round to a particular number of significant figures or decimal places, then do so. If it doesn't, it's always a good idea just to go to 2 decimal places. So the angle that the line AG makes with the plane ABCD is 27.71 degrees. Thank you and see you next time. Hasta la pizza, arrivederci, au revoir.